A curve has a slope 2x plus 3 at each point on the curve. That is a awkward way of saying a curve, meaning f. So a curve, we'll call that f, has a slope of 2x plus 3. That means the formula for the slope, the formula for slope of f, that formula is 2x plus 3. But that's what f prime is. F prime is always a formula for finding the slope of f. So in an awkward, obviously tricky fashion, they have told you in this first sentence that f prime is equal to 2x plus 3. Which of the following is an equation for the curve? So we're looking for the curve as the curve passes through the point 1, 2. So that means we have some sort of f that has a point 1, 2, but we are looking for the equation of the curve. Common misperception would be to think we're looking for the equation of the line tangent. We are not. Which of the following is an equation for the curve? This is a fundamental theorem problem. They're giving you a rate. They're asking you to find f. So we are starting with f prime. We're trying to find f. So if you think of Danica's chart, we're starting with f prime, trying to come over here to f. So we're going this direction. That's the fundamental theorem of calculus. So what I remember is, if I integrate from x equal 1 to, I don't know what x, and I integrate f prime, now I shouldn't have these two variables be the same, so we'll back up and make that a t. Again, don't be on autopilot, think as you go. So the fundamental theorem says this can become f of x subtract f of 1. So the fundamental theorem provides a way to find the formula for the graph of f. Rearranging, I need more space here, so we're going to copy this page and then do it again. So I'll erase this. Move this up. Oops, that didn't work. So we'll just rewrite it. So what I'm starting with is, I know now that f of x must equal f of 1 plus the integral from 1 to 2 of f prime of x dx. Therefore, f of x will equal, f of 1 is 2, because that was a point on the graph of f. To find this integral, I know the formula for f prime. The formula is 2x plus 3. I solve that integral by finding the antiderivative. Two things adding, I can find the antiderivatives separately. 2 is a multiplying constant. The antiderivative will become x squared over 2. The antiderivative of 3 is 3x, bar 1 to 2. So now I know that f of x must equal 2 plus, this will become just x squared, but I have to plug in the values. So plug in 2 squared plus 3 times 2, subtract, because I'm going to be subtracting two terms, I need another parenthesis. Plug in the 1. And then another parenthesis here, although these parentheses really weren't needed because I'm adding. So those two parentheses aren't really needed. Oh, mistake. Got to back up. I should not have integrated between 1 and 2. That 2 is a y-coordinate. This is an x-coordinate. So I'm going between 1 and x, which means here, the x that I'm plugging in will make this equal to simply x, and this also x. So now we have f of x equals 2 plus x squared plus 3x minus 1 minus 3. So f of x will equal x squared plus 3x minus 2. X squared plus 3x minus 2.